Welcome to the section Clustering, a dating app for your data points. In the previous section, we covered some fundamental concepts of R. In this section, we are going to look at data points, how they can be plotted in multidimensional vector space, and how you can measure the distance between them. This will be done in order to understand algorithmic approaches to find hidden patterns in data by taking these distance measures into account. We'll conclude with a real-life example where the topics learned are directly addressed. In this video, my main goal is to make you understand that data can be seen as data points in a multidimensional vector space. Once you've understood this concept, everything else in data mining just becomes much more easy to understand. Every dataset can be seen as a point cloud in vector space. So what we basically need to understand is that every table can be represented as a multidimensional vector space, and each column of the table becomes one dimension and every row becomes a point in that space. The distance between those points can be measured in various ways. The most basic one is Euclidean, which is basically nothing else than drawing a line between two points, but multidimensionally. If you have multidimensional data, or in other words, if the data frame you are working with has more than two columns, simply plotting data to 2- or 3-dimensional charts doesn't work anymore. It is hard to impossible for many people to imagine a universe with more than 3 dimensions, but this is exactly what we are doing here. Assume we have a 3-dimensional coordinate system and the following table. We can also see this as 3 vectors or 3 points in a 3-dimensional vector space. One point is at 0, 0, 0, one at 50, 50, 50, and one at 100, 100, 100. And as you can see, we can plot those 3 points into a 3-dimensional coordinate system. But since we usually work with data having more than only 3 columns, we have to apply data mining methods for finding hidden patterns in data by reducing dimensions to find connections between individual or a set of data points. But since we usually work with data having more than only 3 columns, we have to apply data mining methods for finding hidden patterns in data by reducing dimensions to find connections between individual or a set of data points. We use aggregations and visualizations for doing so. So since we have seen that data is nothing else but point clouds in a multidimensional universe, we can also measure distance between them. So in 2- or 3-dimensional space, this is simply a line. But how do we do this in higher dimensional space? Basically the same way. Let's look at the formula to calculate the distance between 2 points P and Q in a 2-dimensional space. So we basically take the square root of the sum of the squared distances on each individual dimension. This is known as Pythagoras' theorem. As you can see, you can use the same approach in 3 dimensions and luckily also for n dimensions. This is known as the Euclidean distance. So now you understood that you can simply use any dataset and span a multidimensional vector space so that you get a multidimensional point for every row. And distance between points can be measured and used to tell us something about the hidden relationships between each record in a dataset.